In my last lecture, I explained about features of 8086 microprocessor. In this lecture, I would like to explain about 8086 microprocessor pin diagram and its description. And this is the pin diagram of 8086 microprocessor. In this, we have to see that here it is a 40 pin IC. And it is a dual inline package. We already learned that in last lecture in features of 8086 microprocessor. It is a 40 pin dual inline package IC. Here dual inline package is nothing but this IC contains pins in both sides, and here one side is 20 pins and another side is 20 pins, and first side it contains 1 to 20 pins and another side it contains 21 to 40 pins. And here it is very simple. We have very simple trick to keep all the 40 pins in our mind very easily. Now I will explain the trick, and how I will tell you how the 40 pins remained very easily. And in that, first one is here. First one we have to remind in a stepwise. Here first step is, first of all we have to keep first pin, 20th pin and 21 pin and 40 pin. These are the pins first we kept in our mind. First pin is ground and 20th pin is ground and 21 pin is reset and 40 pin is VCC. This is the first step. In first step we have to keep 40 pins. We have to remind 4 out of 40 pins. We have to remind 4 pins. Those are, first pin is ground and 20th pin is ground and 21 pin is reset, 40 pin is VCC. In second step we have to remind 2 to 16 pins. Here 2 to 16, this is the first step. This is the second step. In first step we have to remind first pin, 20th pin, 21 pin, 40 pin. In second step we have to remind 2 to 16 pins. Here 2 to 16 pins are address and data pins, address and data line pins. Here address and data lines, multiplex address and data pins are start from AD14 and up to onwards we have to keep up to 16 pins. We have to AD14, AD13, AD12, AD11, AD10, AD9, AD8, AD7, AD6, AD5, AD4, AD3, AD2 up to AD0. Here we have to remind second step as 2 to 16 pins. 2 to 16 pins are start from AD14 and from AD0. And in third step we have to keep remaining 3 pins, 17, 18, 19. This is the third step. In third step we have to remind 17 pin, 18 pin, 19 pin, and its circuit needs clock. After the ground it has clock pin. 19th pin is clock pin and 17th pin is non-maskable interrupt. Here we have to keep another important trick, NMI. NMI is nothing but a non-maskable interrupt. Here after interrupt, non-maskable interrupt, next pin is also related to interrupt, INTR, interrupt request. In this way, in these 3 steps we have covered up to left side pins, all are covered in these 3 steps. And these are the 3 steps. First pin is ground and first step is ground and 20th pin is ground, 21 pin is reset and 40 pin is VCC. In second step we have to remind 2 to 16 pins. Those are from AD14 to AD0. And in third step we have to remind 17 and 18 and 19 pins. Here 17th pin is an NMI, non-maskable interrupt, and interrupt means And another pin is also related to interrupt only. INTR, interrupt request. And after the ground it has clock pin. 19th pin is clock. In these three steps we have covered left side pins. Now we have to see that right side pins. Here right side pins are in fourth step we have to keep AD15 to S7. This is the fourth step. Here AD15 to BHE7. Here here we have to covered already up to 2. We have to covered AD14 pins. In features of the microprocessor we learned that it contains 20 address lines and 16 data lines. Here in that point we have covered how many data lines? Here we have to cover 15 address lines and data lines, and remaining are in address lines. In total 20 address lines, it covers 15 address lines, and out of 16 data lines it covered 15 data lines. Remaining one data line and one address line is that 39th pin AD15. Here we have to stop here, and in the same the opposite pin is the AD15 continuation, and after that A16, and we have only 16 data lines, and remaining we have address lines. Total address lines are 20 lines in the 8086 microprocessor. So A16, A17, A18, A19. Corresponding to that we also have status pins, bus status pins. These are S3, S4, S5, S6, S7. These are start from S3, S4, S5, S6, S7. These are the continuous pins. This is the fourth step. And in fifth step we have to remind 30 to 33 pins. These are the in fifth step. These are the minimum and maximum bus high enable, and S4, S5, S6, S7. Here these are the continuation, and after that address lines are also completed with up to A19. After that we have one pin BHE. BHE is nothing but a bus high enable. This is the in fifth step we have to kept remind BHE as /S7 minimum or maximum mode pin and RD bar. This is the fifth step. In fifth step we have to remind BHE bar or S7 minimum or maximum bar RD bar. RD bar is used for reading. And then sixth step is we have to remind 24 to 31 pins. Here 24 to 31 pins are minimum or maximum mode pins. Here minimum or maximum pins, first we have to keep in these 8 pins. We have 8 minimum and maximum mode pins. In 31 pin is RQ or GTO bar and hold. First we have to left side maximum mode pins, and after that we lent minimum mode pins. In maximum mode pins are RQ bar, GTG bar and RQ bar / GT1 bar. These are the request pins, and lock S2, S1, S0, QS0, QS1. First we lent maximum mode pins, after that minimum mode pins. Hold acknowledge, write M by N/IO bar memory input output, data transmit or receive, data enable, arithmetic latch enable, address latch enable, and interrupt acknowledge. This is the sixth step. And in seventh step remaining 2 pins, those are test and ready. These are the 23 and 22 pins. So in this way, if you learnt the pin diagram of 8086 microprocessor in this way, by using these steps you can easily remind these pins of 8086 microprocessor very easily in your examination point of view, and in your interview point of view, and in any competitive exams. And So these are the total 7 steps. In 7 steps we completed total 40 pins of 8086 microprocessor. And next one is here is this is the brief introduction of 8086 microprocessor. We already learned these points in features of 8086 microprocessor. First one is Intel 8086 is a 16-bit HMOS microprocessor and it is available in 40 pin chip. It uses a 5 volts DC supply. It uses a 5 volts DC supply for its operation. The 8086 uses a 20 line address bus. So we already learnt in the features of 8086. It has 20 line address bus and it has 60 line data bus. The 20 lines of the address bus operates in multiplexed mode. These are operated in multiplexed mode. That are the pins we have seen in AD14 to AD0 and AD15 to AD0. These are the multiplexed pins. And the 16 low address bus lines have been multiplexed with the data. 4 higher address bus lines have been multiplexed with the status signal. We already observed that in pin diagram of 8086 microprocessor. And AD0 to this is the description of 8086 microprocessor. Now we have to see the description of 8086 microprocessor. In the description, first one is we have to discuss about AD0 to AD15. Here AD0 to AD15 are nothing but address or data bus. Address or data bus. Here these are lower order address bus. They are multiplexed with data. Here in address buses it has lower byte and upper byte, and in that those lower byte and upper byte, the lower byte address bus is multiplexed with the data. And when AD lines are used to transmit memory address, the symbol is instead of AD. Here, if we have to transmit memory address only instead of data, then the symbol A is used instead of AD. For example, A0 to A15. When data are transmitted over AD lines, the symbol D is used in place of AD. Whenever we want to transmit the only data lines, then we simply represent it in D instead of AD. For example, D0 to D7. Here multiplexing concept. We have to first of all know about what is multiplexing. Here multiplexing is the process of combining more signals into a single signal, and it combines here in this microprocessor. It combines both address and data. It is used for reducing the space and bandwidth, and occupies it when by using multiplexing process we have to reduce the space which is occupied. So whenever we want to address, if you want to access address, then it only by using one operating pin we have to select only address, and if you want to data we only select data. This is the purpose of multiplexing. And another one is A16 to A19. A16 to A19 pins are higher order address pins, higher order address bus. These are multiplexed with status signal. We already saw in the pin diagram of 8086 microprocessor is that here AD0 to A0 to A15 is the lower order address bus, and remaining A16 to A19 is the higher order address bus, and these higher order address bus is multiplexed with status signals, and those are from S4 to S6. And next one is S2, S1, S0. Here S2, S1, S0 are nothing but a status pins. These pins are active during T4, T1 and T2 states and is returned to passive state. And when ready is inactive. 111 during T3 or TW when ready is inactive. These are used by the 8288 bus controller for generating ALL, the memory and input output operation, access control signals. Any change these are access control signals. These S2, S1, S0, and these are called access control signals. Any change in S2, S1, S0 during T4 indicates the beginning of a bicycle. Especially the status pins are used for checking the bus status. Here we are using bus. Bus is nothing but a group of conducting wires which are used to carry the address and data. To carry the address and data, we are using bus. To indicate the bus cycle and bus status, we are using status pins. Those are S0, S1 and S2. And here is the table that is to check the status of the bus cycle depends upon the S2, S1 and S0. In first one we have to see that 0, 0, 0 and 0, 0, 0. In 0, 0, 0, that means if the S0, S1, S2 pin shows 0, 0, 0, it means interact acknowledge. And if it shows 0, 0, 1, it means read input output port. It is the meaning of reading input output port. And 0, 1, 0. Here it shows 0, 1, 0. When it shows 0, 1, 0, it means write input output port. And 0, 1, 1. If it shows 0, 1, 1, then it is halt. And 1, 0, 0. 1, 0, 0 means code access. And 1, 0, 1 means read memory. And 1, 1, 1, 0 means write memory. And 1, 1, 1 means passive state. These are the characteristics of the bus cycle depends upon the S0, S1, S2 status pins. And A16 or S3, A17 or S4, A18 or S5, A19 or S6. The specified address lines are multiplexed with the corresponding status signals. We already talked about this point. Higher order address bus is mixed with or multiplexed with status signals. And S4, S3 depends upon the S3 and S4. This is the function of S3 and S4. Here 0, 0. Here if S3, S4 indicates 0, 0, then the function is extra segment access. And if it shows 0, 1, then it is the indication of stack segment access. And if it shows 1, 0, then it is the indication of code segment access. And it shows 1, 1, then it is the indication of data segment access. Depends upon the S3 and S4 status. This is the function that occur in 8086 microprocessor. And another one is HE or SC, bus high enable status. Here HE is nothing but a high enable. Here this is indicates the bus high enable status. During T1 it is low, and it is used to enable data onto the most significant half of data bus D8 to D15. It enables only, it shows whenever it shows 1, that means we have to we already talked about we have to multiplex the address and data. Whenever we want to access only data, then the bus high enable pin is 1. Then it takes only data D8 to D15. And 8-bit device connected to upper half of the data bus use BHC signal. It is multiplexed with the status signal S7. S7 signal is available during T2 and T3 and T4. This is about A16 to A19 pins, and again HE and SA pin. And next one is first one RD bar. Here RD bar is nothing but a active low pin. RD bar is nothing but this is used for read operation. Whenever it wants to read, for reading operation, RD bar pin is low because it is a active low pin. If this indicates active low pin means it is only active for whenever input is 0. And it is an output signal. RD bar is an output signal, it is not an input signal, and it is active when low. It is active only when it is low. And ready. This is the acknowledgement from the memory or slow device that they have completed the data transfer. The signal made available by the devices is synchronized by the 8284A clock generator to provide ready input to the microprocessor. The signal is active high, and the ready pin is used for whenever the data transfer completed, then the ready pin is our slow device that they have completed the data transfer. Ready pin is used for data transfer, and the signal made available by the device is synchronized by the 8248 clock generator to provide ready pin to the microprocessor. The signal is active high. Here RD bar is a active low pin and ready pin is a active high pin. And second, and another one is INTR. Here INTR is nothing but a interrupt request. This is a triggered input and this is sampled during the last clock cycles of each instruction for determining the availability of the request. If any interrupt request is found pending, the process enters the interrupt acknowledge cycle. This can be internally masked after resulting the interrupt enable. This signal is active high and has been synchronized internally. Suppose if you want to stop your program in the middle of the execution, then by using interrupt request you can stop the execution of the program. This is the use of interrupt request. And non-maskable interrupt, NMI. NMI is nothing but a non-maskable interrupt. This is an edge-triggered input which results in a type 2 interrupt. Here we have so many types of interrupts, and NMI, especially NMI, is related to type 2 interrupt. A subroutine is then vectored through an interrupt vector lookup table which is located in the system memory. NMI is non-maskable internally by software. It is a non-maskable interrupt, that means it is a not a hardware interrupt, it is a software interrupt. A transition made from low to high initiate the interrupt at the end of the current instruction. This input has been synchronized internally. And another one is INTA, interrupt acknowledge. Interrupt acknowledge, it is a active low pin. Active low pins, it is active only when it has input when it is 0 during T2, T3 and TW of each interrupt acknowledge cycle. And another one is minimum or maximum mode. Minimum or maximum mode pins. This pin signal indicates what mode the process will operate in. We already learnt about in features of 8086 microprocessor is that it operates in two modes. First one is maximum mode and second one is minimum mode. So this minimum or maximum mode indicates that which mode the processor has to be perform or operate. And RQ bar, GT1 bar, RQ bar or G20 bar. Request are grant pin. These are the request and grant pins. These pins are used by especially local bus masters, used to force the microprocessor to release the local bus at the end of the microprocessor current bus cycle. And each of the pin is bidirectional. RQ bar, G20 bar have higher priority than RQ bar by GT1 bar. Here RQ bar slash GT0 bar has higher priority compared to RQ bar by GT1 bar, and it is a bidirectional pin, and these are used to force the microprocessor to release the local bus at the end of the microprocessor current bus cycle. This is the use of request or grant pins. And next one is lock bar. Here lock bar is also it is an active low pin. It indicates that other system bus masters have not been allowed to gain control of the system bus. While lock bar is active low, the lock signal will be active until the completion of the next instruction. Actually, lock bar is an active low pin and it indicates that other system bus masters have not been allowed to gain control of the system bus while lock is active low. The lock signal will be active until the completion of the next instruction. Whenever the first instruction is executing, the lock signal, by using lock signal, it will be locked, and after completion of next instruction, it will be active. And test bar. This examined by a wait instruction. If the test pin goes low, execution will continue, else the processor remains in an ideal state. The input is internally synchronized during each of the clock cycle on leading edge of the clock. And another one is clock input. The clock input provides the basic timing for processing operation and bus control activity, and it is an asymmetric square wave with a 33% duty cycle. This is the clock that we used in 8086 microprocessor. In features of microprocessor, we already learnt about. For 8086 microprocessor, we have to apply 5 MHz clock frequency. And next one is reset pin. Reset pins are this pin requires the microprocessor to terminate its present activity immediately. Whenever we want to terminate the present activity immediately, then the reset pin requires, and then reset pin is used. The signal must be active high for at least 4 clock cycles. This is a mandatory. The signal must be active high for at least 4 clock cycles. And another one is VCC. Here we have to give plus 5 volts DC power supply, and GND means ground. And another one is QS1, QS0. Here QS1, QS0 are the Q status. These signals indicate the status of the internal 8086 instruction queue according to the table shown below. Here QS1 and QS0 are used to show the indication of the status of the internal queue. Here in 8086 microprocessor, it also contains Q. Q is used to increase the speed of the microprocessor. Here in Q, it will perform first in first out operation, which is used to increase the speed of the microprocessor. According to the table shown below, the microprocessor takes status QS0, QS1. Whenever QS0 and QS1 are 0, 0, then it shows no operation. Whenever it shows 0, 1, it means first byte of opcode from Q. Whenever it shows 1, 0, then empty the Q. And whenever 1, 1, subsequent byte from Q. This is the depends upon the status. This is the depends upon the QS1 and QS0 pins. This is the status. And dt by r is nothing but a data transmit or receive. This pin is used to for data transmission and reception, and this pin is required in minimum systems that want to use an 8286 or 8287 data bus transceiver. The direction of data flow is controlled through the transmitter or receiver. And another pin is data enable, DEN data enable. This pin is provided as an output enable for the 8286 or 8287 in a minimum system which uses transceiver. DN is active load during each memory and input-output access and for INTA cycles. Another one is hold or hold acknowledge. Hold indicates that other master has been requesting a local bus, and this is an active high pin. The microprocessor receiving the hold request will issue HLDA as an acknowledgement in the middle of a T4 or T1 clock cycle. And ALE. ALE is nothing but a address latch enable. ALE is provided by the microprocessor to latch the address into the 8282 or 8283 address latch. It is an active high pin pulse during T1 of a bus cycle. ALE signal is never floated and it is always integer. And these are the some of the this is the pin diagram of 8086 microprocessor, and we learned that how we learned some of the tricks, how we kept remind all those 40 pins of 8086 IC microprocessor very easily, and we learnt about description of 8086 microprocessor and clear explanation of